frequency of sound waves. The vibrations of tuning fork result in generation of series of compression and rarefaction in air. More detailed observation shows that the actual variation in the air density and pressure are as shown here. If any object vibrates in the air, such sound waves are produced in the air. One compression and one rarefaction together forms one cycle of the wave. The number of cycles formed in the air in 1 second will be decided by the number of times the prongs of the tuning fork or any other vibrating body vibrates back and forth. That is, the number of vibrations of the tuning fork in 1 second. Number of such cycles that are produced in the air or any other medium per second is called as the frequency of the sound wave. The frequency is measured in hertz. If one cycle is completed in 1 second, the frequency is said to be 1 hertz. A tuning fork having a frequency of 512 hertz is shown here. It means that the fork vibrates 512 times per second. These vibrations will set 512 cycles of compression and rarefaction in the air per second. Thus, the sound generated by the fork will have a frequency of 512 hertz. The frequency of a tuning fork is decided by the dimensions of the prongs, such as length and thickness, as well as material used for making the fork. Come, let us now perform an interesting activity. Activity. Let us take 7 porcelain balls of the same size. Now, fill each of the ball with varying amounts of water in an increasing order. Let us now arrange them in such a way that the balls form a semicircle. This arrangement is referred to as the famous instrument called Jal Tarang. Now take a pencil and strike gently at the rim of each ball filled with water in succession. What do you hear? You will hear pleasant sounds produced by the balls. You will also notice that each ball produces a different sound. Why is it so? Come, let us know about it. When a ball is struck, waves are set up in the air column above the water level in the ball. The frequency of the generated wave depends on the height of the air column inside the porcelain ball. Since the water level in each ball is different, the height of the air column in each ball is also different. Therefore, the frequency of sound generated by each ball will also be different. So, the sound generated is different. Thus, from this experiment, we understand that there is a relation between the frequency of generated sound and the height of the air column in the ball. A bowl with minimum water produces a sound with a higher frequency, whereas a bowl with maximum water produces a sound with a lower frequency. Do you know? There are many apps available for measurement of sound frequency. With the help of your teacher, you can use the app to measure the frequency of the sound generated from each bowl. This experiment can also be done using stainless steel pots of different sizes. After performing the activity to understand the relation between the frequency and sound with the help of a musical instrument, let us now study about the sound and music in the next part.